Hello and welcome to the Quality Excellence channel. I'm Mayank Agarwal, and in today's Lean Six Sigma video, we're covering Chapter 30, Interactions, Multi-Level Factorials, and Creating Experiments. You tweak one thing, it improves. A small adjustment, a minor calibration, and suddenly you're seeing positive results. Tweak another, it gets better. Encouraged by your initial success, you try another adjustment, and the improvements continue. Change both, and suddenly, it all falls apart. The progress you made vanishes, replaced by unexpected errors and system failures. This is the challenge of complex systems. Hidden connections influence your outcomes in unexpected ways. These systems are intricate webs of interconnected components, where a change in one area can have ripple effects throughout the entire structure. Welcome to Design of Experiments, or DOE, a structured method to reveal how factors in your process interact. It's a systematic approach that helps you understand the relationships between different variables and their impact on your desired outcomes. Think of DOE as conducting an orchestra. Each factor is an instrument, but the real magic is in their harmony. It's not just about the individual sounds, but how they blend together to create a beautiful melody. The secret? Interactions. When the effect of one factor depends on another, you unlock the true potential for optimization. Understanding these interactions is the key to fine-tuning your process and achieving optimal performance. For example, does increasing temperature improve yield? It depends, maybe on pressure. The effect of temperature might be different at high pressure versus low pressure. Understanding these dependencies is the key to innovation. By identifying and leveraging these interactions, you can unlock new possibilities and create groundbreaking solutions. We'll show you how to uncover interactions using smart experimental strategies like factorial designs. These designs allow you to efficiently explore the effects of multiple factors and their interactions. We'll explore simple two-level designs, when to use more levels, and practical tips for success. By the end, you'll see your process as an interconnected system, a hidden symphony waiting for you to conduct. Let's dive in and discover how to make your experiments sing. We'll provide you with the tools and knowledge you need to orchestrate your processes and achieve harmonious results. Ready to find the music in your data? Let's get started. Prepare to unlock the hidden potential within your data and transform your processes into a masterpiece of efficiency and effectiveness. What's an interaction really? It's a term we hear often, but its true significance can sometimes be overlooked. At its core, it's when two or more factors combine, influencing each other in a dynamic way. Think of it as a synergy, where the whole becomes greater than the sum of its parts. This combination creates an effect you'd never see by testing them one at a time. It's about understanding how these factors work together, not just in isolation. Their combined impact is more or less than the sum of their individual parts. The relationship between these factors can amplify or diminish the overall outcome. This is precisely what makes Design of Experiments, or DOE, so incredibly powerful. It allows us to uncover these hidden interactions. This is a huge advantage compared to the traditional one-factor-at-a-time testing, where you only examine each factor in isolation. To illustrate, imagine a hospital cleaning experiment. You might find that a high disinfectant concentration works exceptionally well when paired with a microfiber cloth, leading to superior cleanliness. However, that same high concentration might prove far less effective or even detrimental when used with a cotton cloth. In this case, the effect of the disinfectant is heavily dependent on the type of cloth used. The cloth and disinfectant interact. And that's a perfect example of an interaction in action. Because of the interaction, you simply can't answer the question, which disinfectant is best, in isolation. You absolutely must also ask, with which cloth will it be used, to get a complete and accurate answer. This concept of interactions isn't limited to just cleaning. It's truly everywhere. You'll find it in baking, agriculture, marketing, because interactions fundamentally shape outcomes in countless processes. Ignoring them is like trying to navigate with a map that's missing half the roads, leading you down the wrong path. Therefore, recognizing and accurately measuring interactions gives you the complete picture, allowing you to make informed decisions and optimize your processes. Ultimately, it's the critical difference between simply guessing at the best course of action and truly knowing what will work. DOE provides the tools and framework to help you find these often hidden relationships between factors. That's how you move away from inefficient trial and error methods and progress towards true process mastery, where you have a deep understanding of all the key factors at play. So let's dive in and see how this all plays out with a simple practical example. To understand interactions, let's contrast them with main effects. The average impact of a single factor. Suppose you test two popcorn brands and two microwave power levels. The main effect tells you which brand, on average, pops more kernels. But what if brand A excels at high power and brand B only works at low power? The averages might look similar, but the story is hidden. Plot the results and you'll see the lines cross. A classic sign of interaction. The best brand depends entirely on your microwave's power. Without understanding interactions, you'd miss the secret to perfect popcorn. Main effects ask, which is better overall? Interactions answer, it depends. This is the leap from good to great experimentation. Interactions reveal the real recipe for success. That's why DOE is so powerful. Let's see how to design experiments that uncover these effects. Ready to hunt for main effects and interactions? The 2 circumflex K factorial design is your go-to tool. 2 inches means 2 levels per factor, low and high. K is the number of factors. With 2 factors, you need just 4 runs to test every combination. This efficiency lets you calculate main effects and interactions with minimal effort. Add a 3rd factor, and you only need 8 runs to explore all possibilities. You get main effects, 2-factor interactions, and even 3-factor interactions, all from a small experiment. The design is balanced and orthogonal, so effects don't get tangled. It's a clean, powerful way to screen for what matters. For many problems, a 2 circumflex K factorial is the perfect starting point. It quickly identifies the vital few factors driving your process. Factorial designs make experimentation efficient and insightful. Let's see what happens when you need more than 2 levels. Sometimes, more is more. 2-level designs are great for finding trends, but what if the best setting is in the middle? Enter multi-level designs. Add a middle level to detect curves and sweet spots. For example, testing 1, 2, and 3 tablespoons of coffee might reveal the perfect scoop is in the middle. The same goes for temperature. Maybe the optimum is between your low and high settings. 2-level designs can miss these peaks entirely. Adding a center point or moving to 3 levels lets you fit a curve and find the true optimum. The trade-off? More levels mean more runs, sometimes a lot more. A 3-level, 3-factor design jumps from 8 to 27 runs. That's a big investment, so use 2-level designs to screen, then add levels for critical factors. Balance detail with resources. Smart design means starting simple, then zooming in where it matters. That's how you optimize without getting overwhelmed. Designing a great experiment is just the start, the foundation upon which all your subsequent efforts will rest. It requires careful thought, meticulous planning, and a clear understanding of your objectives. But even the most brilliant design is useless if the execution falls short. Execution is everything. It's where your ideas meet reality, where your hypotheses are tested, and where your data is generated. First, choose a response variable you can measure reliably. This is the cornerstone of your experiment, the metric by which you'll judge success or failure. If your measurement is noisy, meaning it contains a lot of random variation, your results will be too. You'll struggle to discern meaningful patterns from the background clutter. Validate your measurement system before you begin. Ensure that your instruments are properly calibrated and that your procedures are consistent. Second, document everything: objectives, factors, levels, and run order. This creates a clear record of your experimental process, making it easier to analyze your data and replicate your findings. Keep a detailed logbook. Record every observation, every adjustment, and every deviation from your original plan. Third, understand confidence. It's a crucial concept in statistical analysis. Statistical significance isn't certainty. It's about confidence levels. It tells you the probability that your results are not due to random chance. Combine stats with practical sense. Don't rely solely on statistical significance. Consider the real-world implications of your findings. Fourth, use a sequential approach. This allows you to learn and adapt as you go, making your experiment more efficient and effective. Start broad with a screening design, then focus on key factors. This helps you identify the most important variables early on, saving you time and resources. Don't try to answer every question at once. Break down your research into manageable steps. Finally, let the data guide you. Your results should inform your next steps, not your preconceived notions. Be open to surprises. Don't cling to your initial hypothesis. Sometimes the most interesting discoveries come from unexpected results. The goal is discovery, not confirmation. Embrace the unknown and be willing to challenge your assumptions. Good experiments are built on smart planning and disciplined execution. They require a combination of creativity, rigor, and attention to detail. These habits separate successful experiments from wasted effort. They are the key to unlocking meaningful insights and advancing scientific knowledge. Use them, and your results will be clear and actionable. You'll be able to make informed decisions and drive progress in your field. Remember, even the best design fails without careful execution. Meticulous attention to detail is essential for ensuring the validity and reliability of your results. Let's see how software can make this process easier, streamlining your workflow and enhancing your ability to analyze data. Enter Minitab. Running a factorial experiment is more than mixing ingredients. It's about planning, randomization, and analysis. For simple designs, you can do the math by hand, but as experiments grow, software like Minitab becomes essential. Minitab guides you through setup, define factors, set levels, and generate your experimental plan. It randomizes run order, protecting you from hidden variables like temperature shifts or operator fatigue. After running your tests, enter your results. Minitab does the heavy lifting. It calculates main and interaction effects and creates clear charts to show what's significant. Interaction plots reveal how factors work together. The software turns raw data into actionable insights. You focus on the science, Minitab handles the stats. That's how you move from data to discovery fast. We've explored the essentials of modern experimental design: interactions, main effects, and multi-level designs. Testing one factor at a time is slow and misses the real story. Main effects show broad trends, but interactions reveal the critical context. Factorial designs let you uncover these effects efficiently. When you need to find an optimum, add more levels, but balance detail with effort. The art is knowing when to go deeper. Success comes from smart strategy and disciplined execution. Choose the right response, document your work, and use a sequential approach. Software helps, but your expertise is irreplaceable. Combine good design with careful execution, and you turn guesswork into discovery. That's the power of smart experimentation. DOE isn't just for statisticians, it's for anyone solving problems or creating something new. Start small, pick a simple problem, choose 2 or 3 factors, and run a basic experiment. Use the tools we've discussed to plan, collect data, and look for main effects and interactions. That first aha moment when the data reveals a hidden secret is incredibly rewarding. Every experiment is a learning opportunity, even if it doesn't yield a breakthrough. Sometimes, knowing what doesn't matter is just as valuable. Build a culture of inquiry, let evidence, not opinion, guide decisions. The world is full of complex systems waiting to be understood. Factorial designs and the search for interactions give you a new lens on your world. So go forth, experiment, and let the data tell its story. Your next discovery is just one well-designed experiment away.